What? Super lame. Yeah. Oh, it's so exhausting and draining.
At this point, you can get 60. Not just catch up on the assignment.
Yeah, that's why. But like, yeah.
I don't even. Some things are so irrelevant. Like it's a lot of information. Confused us when just looking back.
So yesterday we did 20, 21, and 2022 exam. Huh?
Did you say we were moving on?
Moving on. Today? No. I said for the remainder of the week we're going to do revision for your test.
I would say.
Oh, am I? Guys, I'm getting old. Help me. But what did I say? What did I say?
I said it's fine. We can move.
I don't know. You'll see. You know what, man? This revision today, you guys will tell me how quickly we must get it done because I just need to share these solutions and amend the solutions that I shared with you earlier due to it being blurry. But you'll see that they're asking the same questions. Okay, so let's start with 2023, the exam, to look at the type of questions that they can ask for your learning unit. So we are looking at question 3, question 4, question 5, and question 6. Right. Maybe let me also just open up the let me just open up the actual test, or should I say in this case exam. Show. Yeah, you see, you got your multiple choice. Yes, I believe so. Yes, I am recording. I am recording. All right. Ish. Can you guys see? Okay, so we're starting here, question 3. Here, what are they asking? They're asking us to do the line of best fit. Let's see. Question 3.1. Oh, let me zoom in. Question 3.1. All right. By completing the table below and then applying the relevant formula, determine the line of best fit for this bivariant data set. Okay, bivariant, it just means 2 variables. What variables do we have here? It says the following indicates the years of traveling experience. A sample of salespeople working for Munchkin Pty Ltd and their responding expenses claims in thousands of rands over the last month. Okay, so they are looking at traveling experience in years. Is there a relationship between traveling experience in years and last month's expenses? Right. So if we quickly run through it, or just look, 8, 5, 1,000, 17, 8,000, 10, 6,000, and 5, 4,000. So there seems to be a correlation there. 14, 9. So that is an outlier. But you can see the more years of experience traveling, the more your monthly expenses typically will be. What? Why do you say? Why did I say? It's an outlier because if you see 14, you've got 9,000 there, right? But if you look at 17, it's 8. So you do get more monthly expenses, but 17 should be more than 9. And if you look at 10, 10 is more than all the ones that are less than that, because you get 6 there, but it's not more than 17. So that is still in line. So 14 is the one that is doing its own thing, isn't it? So that's what I meant. Okay. But we know that not all our data is always going to, right? Yeah, going to be straightforward. So here, like we did yesterday, all you're trying to do is establish your linear regression equation. Okay? So you're trying to look for A and B in order to do that. So let's zoom in a little bit. So obviously, you've got your data. First thing that you want to do, okay, is get your summations of x, xy, and obviously y, and then x squared, and then obviously the number of variables we have, 1, 2, 3, 4, 5, 6. Okay, so there is our n. Then there's the linear regression equation. Again, we're looking for A and B. And like we mentioned yesterday, we cannot look for A first because we need B in order to calculate A. Okay, so we have to start by finding B. And we then obviously just need to get our formula. This is why we started with getting these, isn't it? So that when we now plug in to our formula to get B, so when we plug in to get B, we have all the necessary data or variables that we need. Okay, once you now have B, now we can find A. Okay, so just be careful, make sure that you know that that big E is the sum of Y, or the sum of X squared, or the sum of X times Y squared, etc, etc. Okay, right, and then once you have A and B, then you can answer 3.1. Then you can get your line of best fit. Okay, right. Hey, I'm feeling cold. I'm feeling hot. I'm feeling hot. I think we need to lower it again. All right, so 3.2, they say if a salesperson has 11 years of travel experience, okay, estimate his or her monthly expenses. So now, remember yesterday, they just wanted us to do the line of best fit. And this is what I was talking about yesterday, where they can take it a step further and actually say, give us an estimate of what the dependent variable will be. And in this case, your dependent variable is obviously your monthly expenses, because we're using years of traveling experience to predict monthly expenses. Can you see that? So I was trying to scroll up to get to this point here. Okay, so we're saying, can you see we don't have 11 here? So we're saying, what if you have 11 years of experience of traveling? What then is likely to be your monthly expenses, all right, for the previous month? Okay, so there, all you need to do is to substitute X with 11, and then you should get an amount there. So there you've got 60, sorry, this is in thousands, so that's 6,550. All right, rands. That's your monthly expenses. Okay, we obviously did not times by 1,000 here, but then that should be your answer. Okay, right, and then the next thing that they asked us here, 3.3, they're saying, using your calculator, compute the coefficient of determination for the data set. Interpret your answer. Coefficient of determination. What is that?
R squared.
100%. What are we measuring with R squared? What are we measuring with R squared? Guys, there's a whole burger that's on the line. A whole burger.
You'll buy those burgers. Yeah, no, we haven't started like that.
Because here it says what? Interpret your answer. So if you don't know what it is, interpretation, those marks are gone. Okay. So your R squared, okay, your coefficient of determination is we're saying how good a predictor is this linear equation that we have put together. That's what your R squared is. Yeah, you're wording it correctly, but at the end of the day, we're trying to see how good is our, should I say, independent variable in predicting the dependent variable. So you are saying it right, but ultimately, what our takeaway is: how strong, how good is our linear equation at predicting our y, which we know is the dependent variable. So here you can now see. In order, again, to get your R squared, can you see here? Oh, here they're saying using your calculator. So I told you guys, you can do all these things using a calculator. Okay, I advise if you want to go that route, there are many YouTube videos which you can use. And then you just need to put in the calculator, that model that you're using. But if you get it wrong, remember, I can't give you any method marks. So if you're using your calculator, chances are you wouldn't have done x, the sum of x squared, the sum of x, the sum of y, etc, etc. Does that make sense? So same principle here. You obviously are not going to do all of this if you are using your calculator, just using your calculator. Okay. So anyway, there's your formula here for R squared. Again, now you just need to put in your inputs. And then once you put in your inputs and you've calculated it, your numerator and denominator, you'll then get your R squared. So this R squared, can you see? We have an R squared of 85%. And here, let's look at the interpretation. Because this is what we need. Oh, goodness. Can you guys see? Okay. I'll zoom in just now. But here it says, an R squared value of 85% of the variance in monthly expenses can be explained by the sales years of traveling experience. Okay, and we know the sales years of traveling experience is our independent, and monthly expenses is our dependent. It's the variable that we're trying to predict. Okay, so we're saying 85% can be explained by our independent variable. Okay, so just take note of those interpretations because they will be asking you for interpretations in your test. Okay, right. So here, next question, question 4. Now they're asking us calculate the following using the appropriate formulae or methods. All right, so here they've given us data. They say the following data indicates the number of customers per week who made a purchase from a local cell phone accessories shop over a random 11 weeks. Okay, made a purchase, number of customers per week. Okay, number of customers per week. So in 1 week we had 149, other week 156. This business must be doing well. In 1 week, 156 customers. That's nice. So here, what did they ask us to do? Calculate the mean, in other words, the average. And you see, this is not necessarily grouped data. So this makes our lives easy. First thing we want to do is, oh, it's actually already ordered. Okay, already ordered. All right. So you just get the sum. We know how to do this. The sum of all our variables divided by the number of variables we have. Okay, this shouldn't give you problems. We've been doing this since primary. Yes, the average. Calculate the average. You must ask for your school fees back if you didn't do this in primary. Then they're asking us to calculate the first quartile. We didn't do any quartiles the last time we met yesterday. I've seen you guys 10 times this week. Said, "Oh, guys." Yo. All right. So the formula, we know it is for the first quartile, it's n plus 1 divided by 4. Okay. We know if it was the what? The third quartile, it would be n plus. What's the formula, guys? For the third quartile?
Plus 3.
Yes. Should be plus 3. What other quartiles do we have?
2.
We have 2, which is also n plus divided by. All of them are divided by.
Cumulative frequency.
Where are you, my sister? Hey.
Divided by that's what's going on this second.
The frequency of quartile or whatever.
Yes. That space there, yeah. So double check that, guys. Or should we look at the end of this? At the end of should have the formulas here somewhere before linear regression. Yes.
So you need to tell me last year they had an assignment.
They had an assignment. It's possible. It's possible. I don't know. I wasn't lecturing the module, so I really don't know. But I think there was a test too. I remember Lisiba talking about a test too. Some of you guys would know. Was there not a test too? So, yeah. Anyway, that is our formula for the guys. You must know all the formulas for your quartiles. All right, just know them. There's a small variation in each of them, isn't it? Okay. So, and we know we've got 6 variables here. Oh, sorry, 11. I'm thinking of the previous question. These are 11 data points. Okay. 11 plus 1 divided by 4. Okay, is giving us 3. So that's 12 divided by 4 is giving us 3. Okay, so we look for the third data point. Isn't this is in order? So this is 1, 2, and then 3. Can you see that? So that is, can you see here? So interpretation, 25% of the weeks had fewer than 164 customers. 25%. Remember, quartiles, we're looking at 25% intervals. Okay. The midpoint, we're looking at 50% of our data. Where does it fall? So we're saying 25% of our data is fewer than, okay, or less than 160, has less than 164 customers coming in. Okay, right. So the next thing, what did they ask? They then asked for the standard deviation. Okay, and here you can see standard deviation for individual data formula is different. Okay, formula is slightly different. Okay, again, we do want the square root of our variance. Okay, so this is the what's under the square root would be your formula for the variance. Okay, just subtract this square root thing. That would be the formula for your variance if we are dealing with individual data. Okay, so again, you can see here we are talking about the x variable minus the average squared. Remember, we were saying, guys, make sure you remember this formula for, but we were looking at grouped data that time. So I'm just showing that commonality, and we're taking the sum of every single variable minus the mean, the average, squared, and then divided by n So here you can see the sum of squared deviations, okay? And then here we're dividing by n, which is 11. And then we're getting the variance, which is 212.63. And then we're squaring that to get our standard deviation, which is then giving us 14. Here, did they ask us to interpret? Nope, they didn't. But what is the interpretation? When we say the standard deviation is 14.53, what are we saying? What are we saying? And I love the fact that she's looking, because that's where, this is when we need to be looking, we need to be doing ChatGPT, we need to be Googling. Because in the test,
Why did you guys
why do we use it? Because it helps. Yeah.
Education.
Yes. We use ChatGPT.
When you use it for the right reasons, it makes sense.
So, is that using it for an assignment is the right?
Guys, you know what? You know, back in the day, they never used to allow people to use calculators in class.
Yeah.
All mathematical stuff was done. You must use your fingers, you must use your mind, you must learn how techniques on how to multiply without calculators.
Right.
Calculators, much like ChatGPT, was something that people were pushing away, saying that no, we're making people lazy, they don't want to work. But
And
now,
when you guys write math exams and pure math exams, are you guys allowed to use calculators? Yeah. When I wrote my exams, we did paper 2, which was without a calculator, and then you had paper 4 with a calculator.
4.
And paper 4.
Metric paper 4.
No, I did GCSEs. But like they made you not use a calculator.
so you see, but now any numeracy related module, we even have specialist calculators for finance, specialist calculators for science.
Make life easier.
They make life easier. So we can focus on being productive. So ChatGPT, we can fight this thing all we want. It's coming in. So what must we do?
Didn't
We must just
change their standards this year? For like last year, you were using, we're allowed to use it.
yes, but you can't use it to write your whole paper.
No, but like
and stuff like
you
that.
can use it for referencing and stuff like that.
Get ideas.
I thought you were not allowed to.
Before you would be literally, I think it was suspended or expelled if you used it, like last year. But this year they changed it.
We know we can't fight it. It's coming in. So we have to work with it. Have to work with it.
The way I'm looking forward to ChatGPT.
Okay.
You've never used an AI.
So what's the explanation?
You've never used an AI.
What is there? What are you managing to see there on standard deviation?
I'm saying it expresses the dispersion.
The dispersion. Okay. So in other words, it helps us to see the spread of our data away from the mean. What is the mean? The average. So most of our data that might not be on the average is what? Where's my standard? 14.58 standard deviations away from the average. Okay? Yeah.
But sir,
Yes.
why is standard deviation under square root and then variance is not?
Square root. Because variance is measuring roughly the same thing. Okay? You're pretty much the variance. What is the distance from the mean? Is what you're really kind of looking at.
So because the standard
The
deviation
formula
is
sheet is not the same.
it only gives us variance, it's not standard deviation.
Yeah, you guys, remember you have to be very careful. This is a square root of S2. This is your standard deviation. This is your standard deviation. This is S.
No.
This is the whole. Yes, can you see? This is your, this inside, under the square root, is your variance, isn't it? Can you see that? And then here we just said square of this. Yeah. So, yeah, guys, again, and thank you for highlighting that. We need to look at the formula sheet in the back and see what are they giving us in the test or the exam, and then get used to whatever formula we are going to use. Because otherwise you'll be like, they didn't give it, but then they have, or there might be a formula that is too simple. Like, did they give us the mean? Like the average in the back there? They haven't given us the mean. They have. These guys, they're being too kind. The average. No, we did this in primary. We did this mean. No, we all did this thing in primary. Yes, grade 6. The average, guys. No, guys, no. No, guys, no, I refuse. The average.
Yeah, we've been doing the average, mean, median. I remember doing it with 12 and standard deviation in the company.
Yeah, we revisited these things, but we started this thing in grade 6.
Said, do you expect us to remember? I was playing with rocks. I can never.
All right, so here they say now, what is the coefficient of variation for the data set, which is what we were looking at just now. So you can see here, CV, that's your formula, okay, for your coefficient of variance, okay? And again, fortunately, they didn't ask for interpretation. But guys, you never know, they might ask you guys. So just make sure you read up on that so you can be able to interpret. Okay. All right. Awesome stuff. So there we go. That was our question 4. Then we said 5 and 6 we also need to do. 5 and 6 we also need to do. So what are they asking for in question 4.2? Just before we go on, they asked us to draw a bar chart graphically. Illustrate the results given in the table. So there we've got brand of bleach, all right, number of customers, all right, we've got a total of 50. And this time I did not draw a bar graph because when I brought a bar graph yesterday, people criticized my bar graph. So I've just focused on the things that you need to have in there. So firstly, you obviously need to understand your data. You need to understand you've got different brands of bleach, then number of customers for each of those bleaches. Then you need to draw your bar graph. Your x-axis is obviously going to have your different bleaches, and then your y is going to show the number of customers according to the scale. Then remember that each bar, when it comes to a bar graph, we have spaces. Histogram, no spaces, okay? And obviously the height of each bar needs to be in an alignment with the number of customers, which we noticed yesterday that there were mistakes, isn't it? Yeah. So that is your question 4. Before we go on to question 5. Are we fine? So here, question 5 is the same as what we had yesterday, where they want us to calculate the mode, the median. Here this time they've included the first quartile, all right, for grouped data, all right. The way they like these questions, there's a good chance you might have this thing in your test, okay. And then finally they wanted us to determine the variance, okay. So variance, standard deviation, those things I think are very relevant. Somewhere along the line, you'll probably get this mode, whether it's for single or group data, but I think it will definitely be group data if they do ask that, because again, we did these things in primary. Okay, so anyway, I'm just revisiting the formulas, but I'm not going to spend time on it. Remember, first thing that for us to get the mode, remember the mode is which number in our data set, I'm going back to ungrouped data, which number in our data set appears the most frequent. So when it comes to grouped data, we're saying which class has the biggest frequency, which is the same as kind of saying which is the most common. And if we just look at our data, 50 to 60, we have 21. So that's obviously then our mode, okay? So they under the mode interpretation, they say the mode indicates the most frequently the number of customers fell within 50 to 60 range. Okay, happiness day. We then go on to the median. The median, we said, is the middle number in our data set. And we know to identify that, we need to say number of variables, n, divided by 2, to get the middle of our data set. So we know number of variables, total number of variables is 50. If we add up all these, we're going to get 50. Okay? So 50 divided by 2 gives us 25. So where we have 25 observations, right, collectively, cumulatively, that's our median class. Okay, remember here we have to pick classes because we have grouped data, isn't it? So let's now see. Cumulatively, your first class only has 3 observations. Your second class then has a total cumulatively of 9. Because we are adding, I can only draw on this side. So that's going to be 9. So going to now the third, use a different color. It's going to be, yes, it's going to be 30 to get that. Cumulatively. So 25 is going to fall within that. Can you see that? 50 to 60. So that's how we've now identified, okay, then our median class is obviously 50 to 60. All right. Everybody happy there? Right. So we're just going to finish this, then we'll take a break. The first quartile, again, here you can see the formula there. Quartile 1 lies at n divided by 4. Okay, so n is 50 divided by 4, you get 12.5, which again is going to lead us to 40 to 50, because we know 40 to 50, if we look at 30 to 40, we only have 3. 40 to 50, we only have 6. So 50 to 60. Is that the answer they gave? The 12th observation. Yes. Oh. 12.5. Which is 40 to 50 interval. Okay. Right, so they're saying it is 40 to 50 is a quarter of our data is found in there. It's found in there. Okay, I'll have to relook at that one. But I was imagining that it should be 50 to 60. Yeah, I was imagining that it should be 50 to 60 because we only get, quarter of our data. Okay, but let's leave that one for now. So double check that in your revision to say how have we done the quartiles. I know we did do quartiles for group data in your revision exercises. So I think they're about revision exercise 3 thereabout. We definitely did that. Okay. Then here they're saying use a calculator to calculate the variance. Again, we did that yesterday. And there's our formula for calculating the variance of grouped data. Okay, we have to get obviously the midpoint for all of our classes minus the average, okay, and then obviously squared. Okay, and then we add all of those together and we divide it by n, as you can see over here, and then our variance is going to be 109. Okay, right, but I think let's park it there for now. Let's take our break, and then when we get back, we'll finish off 5.2 and finish off this paper, and then look at question 1 of 2022.